Hello everyone, welcome back to my channel. So this is the second part of higher order derivative, which we have discussed the standard forms of higher order derivative. So now we will discuss the second type of higher order derivative, that means a standard form of derivative. So the question is given, if y is equals to e to the power ax cos bx, then it is given to find yn. So we will start by using, so considering what is given, y is equals to e to the power of ax cos bx. Then for this we have to do the differentiation with respect to x. On differentiating, we know d with respect to x we are doing, so d by dx y, which is equals to d by dx of e to the power of ax cos bx. Then as we have the notations, when we do the derivation for y for the first term, we can write as y1, and then by following the uv formula, we know uv product rule. So what we say, e to the power of ax is our u value and cos bx is our v value. So by using that, I can write it as u, that means e to the power of ax, derivative of v means cos bx, then plus v cos bx, then derivative of e to the power of ax. So this is what we have. Now let's solve this one. So y1 is equals to e to the power of ax, and the derivative of cos x, consider bx as x, then cos x derivative is nothing but minus sine bx, and by following the chain rule, this bx, when we do the derivative for, here I am doing the derivative for bx, as b is a constant value and derivative of x is nothing but 1, and we have the value, here we have the value b. So this is what we have. Now here I can write into b plus cos bx, and derivative of e to the power of x is e to the power of x, that means here it is given ax, and then again derivative of ax, here a is a constant and derivative of x is 1, so we have a value a. So we have to multiply here a. Then I can write this equation as minus e to the power of ax sine bx into b plus e to the power of ax cos bx into a. Now here if you see, we have a common terms, that is e to the power of ax. So y1 is equals to, by taking those common terms, I can write it here as e to the power of ax, then minus sine bx into b plus cos bx into a. So this is what we have. Then now rearrange this one, as I can write y1 is equals to e to the power of ax, then cos, or I can write the a value first, a cos bx, then minus b sine bx. So this is our first equation. Now let's consider this as our first equation. And as we have done in the previous question also, by considering the value of a as r cos theta, and for b I have considered the value as r sin theta. So this will be our second equation, and this is our third equation. Now what we have to do is, we have to do the squaring these two now. That means this equation 2 and 3, we have to do the squaring, and then we have to add those values. So I can write it here as squaring and adding equation 2 and equation 3. So these two will be squaring out. So on squaring, I can write the equation 2 value as a square is equals to r square cos square theta. And similarly, the third equation will be written as b square is equals to r square sine square theta. Then we have to do the addition for this. On adding, we can write a square plus b square is equals to 2. So for this I can write it as, that means r square cos square theta plus r square sine square theta. If you see here, r is a common term, so I can write r square cos square theta plus sine square theta. As we know the trigonometric identity, cos square theta plus sine square theta value is 1. So r square into 1. Then the value will be of a square plus b square is nothing but r square. Then I can get the r value as root over a square plus b square. So we have a value for root. That means, sorry, for r value. And now the same equations, here the equation 3, that means 2 and 3, we will do the divide equation 3 by 2. So on dividing the equation, divide equation 3 by 2. That means by equation 2, okay, by equation 2, on dividing I get the value as b by a is equals to r sine theta by r cos theta. So this is what we have. Now on cancelling the terms, the remaining will be b by a is equals to tan theta. And if you see here, the theta value will be tan inverse b by a. So this is what we have the value for theta. Now we will put all this theta value and again the r and also the value of a and b in the equation 1. So on substituting these values in the equation 1, I can write it as y1, the equation I am writing here, y1 e to the power of ax into a cos bx minus b sine bx. So this is what our first equation. So in that equation, when I substitute the values, I get y1 is equals to e to the power of ax and the a value is r cos theta into cos bx minus the b value is nothing but r sine theta, then sine bx. So I have substituted the values. Now here the y value is r is a common term. So I have taken the r as a common, then cos theta into cos bx minus sine theta into sine bx. So this is what we have the equation. Then also what we have here is, I can rearrange this one to change it as a trigonometric formula. For that I have written e to the power of ax r cos bx into cos theta minus sine bx into sine theta. So this is what we have. Now if you see this one, this is in the form of cos a plus b form. So in that a I have a value called bx and in place of b I have a value called theta. So that means I can write y1 is equals to e to the power of ax r cos bx plus theta. So this is what we have. So similarly, that means for derivative, if we do the derivation for the given equation, the first derivative we will have is e to the power of ax r into r cos bx plus theta. And similarly for y2, just change the values. That means e to the power of ax into r square. Here the power is 1 because we are doing the derivative for the first time. So the power is 1. Here also the theta value, if you see here also the value is 1. So when we write this one for the second derivative, then the derivative equation will change to bx plus 2 theta. And similarly, when we do the derivative for third time, then we can write e to the power of ax into r cube into cos bx plus 3 theta, and so on. Similarly, if you see for the fourth one, the e to the power of ax into r to the power of 4 cos bx plus 4 theta. So this is what we have. And if you go for the nth time, yn will be equal to e to the power of ax into r to the power of n, then cos bx plus n theta. So this is what we have, and we have a value for r. So we have to substitute the value for r in this equation. So e to the power of ax, the value was r is equals to root over a square plus b square. So in similar way, r value is nothing but a square plus b square. So root over will be 1 by 2 into n. Then cos bx plus n. The theta value was, which is equals to tan inverse of b by a. So this is what I am substituting here. The theta value tan inverse b by a. Now on arranging this one, I can write the nth derivative of this equation as e to the power of ax, then a square plus b square to the power n by 2, then cos bx plus n, then tan inverse of b by a. So this is the equation. It means solution for the given equation. Now the third one is, it is given that to find the nth derivative, nth derivative of that means given y is equal to e to the power of ax plus b into sine x. So the equation is given as y is equals to e to the power of ax plus b into sine x. So now we will do the solution for this question. So I can write y is equals to e to the power of ax plus b into sine x. We do the derivative for this function with respect to x. So on doing with derivative, this derivative, so the derivative of y will become y1, and the derivative of e to the power of ax plus b into sin x. The same one, the product rule we will use. So this will be our u and this is our v. So I'm directly writing the equation as, so u, the derivative of u, sorry, first we will write the value of u, that is e to the power of ax plus b, and the derivative of u, derivative of sin x will be cos x, plus v means sin x, the derivative of sin x, and the derivative of e to the power of x will be e to the power of x only. Here the x value is nothing but ax plus b, and the chain rule. What we have, a chain rule is nothing but the derivative of ax means a only, and the derivative of b will be 0. So then I can write the value by arranging y1 is equals to, here e to the power ax plus b is a common term, then I can write cos x plus sin x into a. So this will be our first equation. Now again we can substitute the values for a and b. If you see here, there is no b value. So for that, what I am going to write is, put a is equals to r cos theta. So we have the value for a is r cos theta. And similarly, as we have writing in the previous steps also, and that means in the previous questions, for b value I used to write r sin theta. So here we don't have a b value, so I can substitute the value. If you see here, there is no b value, so for that I am writing 1, which is equals to r sin theta. And for this equation I am writing as it is, that means a is equals to r cos theta. So this will be our second equation, and this is our third equation. So these are the two equations. The same steps, squaring and adding equation. Squaring and adding equation 2 and 3. So directly I'm solving this one on adding, that means squaring a second equation, then it will be written as a square which is equals to r square cos square theta, and then for 1 square is equals to r square sine square theta. So on adding we can get a square plus 1 square is equals to r square sine square theta plus r square cos square theta. So we can write like this. This is our cos square theta and this will be sine square theta. Okay, then let's take the r square as common. So the next step will be written as a square plus 1 plus 1. So 1 square is nothing but 1 only. Then r square, taking common the r square, I can write cos square theta plus sine square theta. So a square plus 1 is equals to r square only, since this value, the value of this will change to 1. Okay, so anything multiplies with 1 will be the same only. Then I get the r value as root over a square plus 1. So this is what we have for the value r. Then again we have to do the division step for equation 3 by 2. So on dividing, I get the value as r sine theta by r cos theta, which is equals to 1 upon a. Then this will change to tan inverse, which is equals to 1 upon a, and the theta value will be equal to tan inverse of 1 by a. So I got the theta value also. Now we will substitute these values in the equation 1. So the equation 1 was y1 is equals to e to the power of ax plus b into cos x plus a sine x. Okay, so now let's substitute the values. So y1 is equals to e to the power of ax plus b, then r sine theta into cos x plus r sine theta into, sorry, it's not theta, the value of r was, a was r sine x into cos theta. Wait for a while, just check it out. As we have a value for a is r cos theta and for b r sine theta. Okay, so the cos x value will be written as, here we have only one, so one value was r sine theta, and for a value we have r cos theta and the multiplication value. Then I will write the next step as y1 is equals to e to the power of ax plus b. By taking r as a common, then the rest of will be changed to sine theta into cos x plus sine x into cos theta. So if you see here, it is in the form of only this part. If you see here, only this part is in the form of sine a plus b. So for this I can write it as y1 is equals to e to the power of ax plus b r into sine. So here if you see any of the value, x is our a value and b is our theta value. So sine a plus b form. So for that, the next derivative can be written as e to the power of ax plus b r square and then sine x plus 2 theta. Then similarly for the third term derivative of the given equation will be written as e to the power of ax plus b r cube then sine x plus 3 theta, and we can do the derivative for nth time, then the answer, that means the result will be written as e to the power of ax plus b r to the power of n, then sine x plus n theta. So this is what we have the nth order derivative. Also we have the value for r. So for that yn is equals to e to the power of ax plus b, and the r value was which we have found, the value of r was root over a square plus 1. So root over a square plus 1, and we have an n here. So this will be written as a square plus 1 to the power 1 by 2 into n. That means 1 by 2. Sorry, n by 2 into then the rest will be sine x plus n, and the theta value is tan inverse of 1 by a. So this is the answer for the nth order derivative of the given equation. Now let's solve the other one. So the other question was given, that means the fourth question, to find the y is equals to sine ax plus b. Suppose this is given and it is given to us to find the yn, that means nth order of the given equation. So let's write it as y is equals to sine ax plus b. So we have to do the derivative with respect to x. So on doing the derivative with respect to x, the equation will change to y1 is equals to, so here we have only one function, so derivative of sine x will be cos x. X is nothing but ax plus b. Again, by following the chain rule for this function, we have a only value. Then the y1 can be written as a cos ax plus b. Then we have a formula of cos theta is equals to sine pi by 2 plus theta. So by using this formula, I can write this one as y1 is equals to a. So this value will be considered as theta. So for that I can write it as sine ax, because here the theta value is nothing but ax plus b. So here I am writing theta is nothing but ax plus b in this particular question. For this question, theta value is ax plus b. So I am writing ax plus b by following the formula called cos theta is equals to sine pi by 2 plus theta, ax plus b plus pi by 2. So this is what I got, the value of first derivative of the given equation. And similarly, if I do the derivative for this equation with respect to x, that means to get the derivative of second time, the derivative for the second time of the given equation, then I can write it as d by dx of y1. So when I write the y1, that means the derivative will change to y2. Then derivative of what we have to find for a sine ax plus b plus pi by 2. So this is what I am having. Then let's see, here a is a constant value and the derivative of sine x will be cos ax plus b plus pi by 2. And for this function, that is by following the chain rule, if I do the derivative for this part, then I get the value only a. Then so these a will get multiplied and I can write a square cos ax plus b plus pi by 2. This is what I got the value. Then so this is also in the form of cos theta, which was the formula of sine pi by 2 plus theta. By following that formula, I can write y2 is equals to a square sine. So this is our theta value. So ax plus b plus pi by 2 plus pi 2. Here it is already present, which was present in the formula. Then y2 is equals to a square sine ax plus b plus 2 pi by 2. Okay, so this is the derivative of the second derivative of the given equation. And similarly, if I do the derivative for the third time, the given equation will change to a square sine ax plus b plus 3 pi by 2. And then y4 is equals to a square sine ax plus b plus 4 pi by 2 up to nth derivative. If you do the up to nth time of the derivative for the given function, then the answer or the result will be written as a to the power of n. So here I just made a mistake. If you see here, this will change to a cube and this will a to the power of 4. And similarly, a to the power of n sine ax plus b plus n pi by 2. So this will be the result of the given function if we do the derivative for nth time. Now the next one is given, fifth one. The function is given to find the y nth. That means nth order derivative of the given function was y is equals to ln ax plus b. Okay, now we will follow the rule. First we have to write the function, then we have to do the derivative for this. On derivating, we get dy by dx, which is equals to the derivative of the given function is nothing but ln ax plus b. So the ax plus b, here I am writing differentiate with respect to x. Okay, now y1 is equals to derivative of ln x will be 1 by x, that means ax plus b, and the derivative of this part will be a. So easily I can write it as y1 is equals to a into ax plus b to the power minus 1, which is the inverse of this part. So similarly for y2, this will change to, so if you see the derivative for this function, that means y1, if you see here, a is a constant value, and then if I do the derivative for this, minus 1 ax plus b to the power minus 2. So minus 1 will change to 2, and the part for this part the derivative will be a. So here it changes to a square, there is a part minus 1, and ax plus b to the power of minus 2. And similarly, if you do the derivative for y3, that means if you do the derivation for the given equation for the third time derivation, the value changes to minus 1 into minus 2 a cube ax plus b to the power of minus 3. And similarly, the fourth derivative of the given function will give the answer as minus 1, minus 2, minus 3, a to the power of 4, ax plus b to the power minus 4. So these are the fourth type up to fourth derivative of the given function. Then if I write the nth order derivative of the given function, then the answer will be a to the power of n minus 1 minus 2 minus 3 up to we get minus n minus 1. Okay, so up to n minus 1, and then the rest of the part will change to ax plus b to the power minus n. Otherwise I can simplify and I can write the y, that means nth order of the function, as minus 1 to the power n minus 1 into n minus 1 factorial a to the power of n ax plus b to the power minus n, or some more step to simplify this one, minus 1 to the power n minus 1 n minus 1 factorial a to the power of n upon ax plus b. So this is what we get the answer for the given function, the nth order derivative. The next one is given, sixth one, which is equals to y is equals to e to the power of mx, and we have to find the nth order derivative of the given function. So for this function again we have to write differentiate with respect to x. So on differentiating, I can write this one as y1 is equals to derivative of e to the power of x will be e to the power of x only, and this derivative will give the answer as m. And the second derivative of the given function will write it as e to the power of mx into m. Because m is a constant value, then e to the power of mx will be e to the power of mx, and this part will give the value as m. So y2 will be m square e to the power of mx. So the third term derivative of the given function m square, derivative of this part is e to the power of mx, and the derivative of the power part will give the value as m. So y3 is equals to m cube into e to the power of mx. So by this we can get the nth order derivative of the given function as e to the power of mx into m to the power of n. So this is what we have the value for the given function. And then the seventh kind of standard form is y is equals to ax plus b to the power m, and we find the nth order derivative. See here, again I can write this one as ax plus b to the power m. So now we have to do the derivative with respect to x. So on doing the differentiation, the equation changes to y1 is equals to m. So derivative of this part will be written as m ax plus b to the power m minus 1, and the derivative of ax plus b will be a. Similarly, the second derivative of this function, first derivative value function, will give the value as m, then the derivative of m minus 1, then this will be written as ax plus b to the power m minus 1 that is 2 into a, and the derivative of this function is a. So y2 will change to m minus 1 ax plus b to the power m minus 2 into a square. Then the third derivative of the given function, let's write the a square here, then m minus 1. So derivative of this part, particular part, will be written as m minus 2, as we have the formula called derivative of x to the power of m will be m x to the power m minus 1. The same way I have written m minus 2 ax plus b to the power m minus 3 into the derivative of this part will be have the value as a. So y3 is equals to a square m minus 1 m minus 2, and then ax plus b to the power m minus 3. And if you see here, if I multiply this value here, then this changes to a cube. Okay, so the nth order derivative of the particular function can be written as a to the power of n m minus 1 m minus 2 up to, we can write this one as m minus n minus 1. So the limit of this value will be, and then ax plus b to the power m minus n. Okay, this is the nth order value of the given function. So the next last standard form of the higher order derivative is y is equals to x to the power of n, and we will find the nth order of this function. So this function will be done the differentiation with respect to x. So after doing the differentiation with respect to x, we get the value as y1 is equals to, so derivative of this value will be m x to the power m minus 1, and similarly the second derivative will be m minus 1 x to the power m minus 1 and minus 1, which will change to minus 2. So minus 2, then y3 is equals to m minus 1 m minus 2 x to the power m minus 3. So this is what the third order derivative of the given function, and for the nth order derivative of the function will be written as m, m minus 1, m minus 2 up to m minus n plus 1 x to the power m minus n. So this is the what we say is nth order of the given function. So these are the 8 standard forms. So by using these standard forms, by using the nth order derivative formula, we can get the answer for any kind of questions which is based on the higher order derivative will be given. So that's it for today. Thank you.